Okay, I'm going to demo my VBA and Lambda file, but it's not just my file, right? I'm following in the footsteps of community members who've shared code, help, and inspiration. So thank you to Dim, Hayden, Brittany, Lorenzo, Jeremy, Julian, Bo, Juan, and Kobe. I'll put this information in the video description. You can also, I mean, this file you can download in the video description. We're going to demonstrate now how do you use this file for like a real match, right? So before the match starts, you just set up a folder, right? So I got an empty folder. Doesn't have to be empty, but you know, it's empty in this case. I don't know the file name yet because the game hasn't started, and I make a file name in order to save this, right? So now let's say the game starts, right? And download the case, which goes to my downloads directory, and then I just move it into this empty directory. And now that I know the file name, right, I put that in here and click Setup Workbook, right? So this is going to create this L1, L2, L3, L4, where you can solve each of the case, each of the levels for the case. You solve in a its own tab, right? Its own worksheet. This is a what if data table here. I know it doesn't look like a table, but it is, right? So these are the problem numbers for level 1. These are the problem numbers for level 2. And then this magic yellow cell is where you put your answer, right? So let's say this is asking us to find, you know, the 3 characters from the left of that word. So equals left is how we do that with that text and that number of characters. Right. And now that I've solved it, you see the color of this change. There's a conditional formatting that checks if these two are equal to each other. Right. So before I did it, it's white. Now I bring that up and we see its color. And it's like, oh, you know, you're probably done. So you can click done. And now it populates the what if table. Right. So let's go back, and you can also look at it deletes the what if table when it's done, because otherwise it could get slow. But you could use these buttons to bring back the what if table. So now you see, like, if I put a 1 in here, right, now it looks up the information. This is just, you know, an X lookup on the case sheet, right? Looking up the question number. So I look at question 4 and I can see, you know, that's what I'm getting given, and that's the answer that I'm calculating. And then, you know, it automatically, when I press the done button, right, it pastes these in here. And I'll show you one other thing it does, right? So let's solve this one also. So what is the sum of the 2 largest numbers, right? So if I do equals text split that, right, by space dash space is there, right? So the, and I want to use this twice. So let's say I put it over here. So then I do what? So I can put something, you know, over here, and then I'm like, so the maximum of this plus the large of this 2, right? The second largest of it. Oh, and text split, you got to multiply by 1 to get to numbers, right? So now I'm taking the max of not just one number, but the whole array, right? There's the array symbol. That gives it the answer. I know it's matching that because I see the color, right? So I can click on done. And now even I haven't pressed anything else other than done, but you know, it's on the clipboard. So I can just, you know, paste it in like that. The other button I can use is this copy button, right? Which copies everything from the previous tab over, right? If I do it again, it's going to say, oh, this, do you want to overwrite it? And I'm going to say, yeah, sure, overwrite. So that just brings the same formula pointing at the same thing. It doesn't work in this case because it's different, but this helps you build one question on the previous question. So that is how that part works. Now we're going to look at the VBA and Lambda itself, right? And or the VBAs, sorry, the Lambda functions, and also some of the built-in user-defined functions and subroutines that are all listed here. All right, so I have them divided up into categories. Within each category, they're alphabetized by name, and then the categories are alphabetized. I mean, the categories are a little loose. Could probably do it differently, but I wanted to have some kind of organization. So the first Lambda function we have here is exists, which simply looks to see, is there this, does this 3 exist in this list? And it does, right? So that's a 1. This, you know, under the hood, this is just using like X match. Does this kiwi exist in this list of fruits? Well, there's no kiwi here, so it says 0. It does not exist. So this is just a lambda I made because I got tired of typing, if X match is greater than 0 over and over again, so I made this version. This is a subroutine. So to run this, to run my subroutines, right, you select what you care about here. So I select this whole 2-dimensional array. And I'm like, all right, well, give me a frequency table of that. So there's the all unique values. And then here are the counts of each one, right? And then the highest one, right? The most common is kiwi. So that's highlighted in this color. And the least, there's 2 tied for the least common. So they're both highlighted in that color. And this is good for bonus questions of whoa, what's the most common or least common? Is unique is another array, which just checks that if all values in the array are unique. So this array from 1 to 10, it is unique, so you get a 1. This array has 2 apples in it, so it says 0. It is not unique. Notice this is case insensitive. Usually in Excel, we do everything case insensitive. So I'm following that. You can also turn this, I'll show you string to array later, right? But it just takes this, just makes this an array with 1 element per letter. This word here, uncopyrightable, has no repeat letters, so the array it's based on is unique. Whereas this word, considerately, has 2 E's in it, right? So it is not unique and returns a 0. All right, next is snake. So we take a 2-dimensional array and flatten it to a 1-dimensional array, but we don't do it in a boring way. We do it in a snake way. So the default here goes to the right first. 1, 2, 3, then it snakes down to 6, 5, 4, snakes down 7, 8, 9. You can specify a direction here, either with one of these arrows here from the prep table, or I've got a named range for arrows here. So if it's left first, right, then you start on the opposite side and it goes 3, 2, 1, 4, 5, goes in a snake pattern like that. You can also do up or down, right? So this is the down first snake goes like that. And that's snake. Shift array moves the array over. Could be 2-dimensional usually, or it could be 1-dimensional. And you feed it, an arrow. The arrow is required in this case. If you put something for fill, like in this case, I put in an X for the fill argument. So it fills in an X for the parts that are empty now. If you don't put in a fill argument, if you leave it blank, then it wraps around, right? So the 147, it falls off the edge and wraps back around. And you can use diagonal arrays for this. So here, everything went diagonal down. Everything, it went 1 to the right and 1 down. And that happened at the same time with this. And, it wrapped around. So the 9, which was originally here, wrapped all the way around to here. Next is X2 call. This is one of my most common lambdas. If you use, here's the original, the built-in 2 call, which takes a 2-dimensional array and makes it a column. It has a cleanup. This number 3, option 3, gets rid of blanks and errors. But look what happened. Why are these blanks still here? And the answer is because they're not really blanks. They're I have these little empty strings here, right? So 2 call will not clean out empty strings, which is one of the things I don't like about it. So I made my own 2 call, which clears out the empty strings and the error, and the empty, the true empties are all cleared out. And it also gives you the addresses, right? So you can use this to make a lookup table if you want. I've also got options for this. You can tell it to not show the addresses, right? If you don't want the addresses. You can tell it not to clean. This is no clean, no address. So if I tell it not to clean, I get the whole original thing. You can have it go in column major order, right? Normally Excel loves row major order, which is, to the left, to the right first, and then down to the right. Column major order is sometimes called the Fortran order, right? Is down first, then down, then down. So column major order is possible. And this I also use to reverse arrays. So anytime I need, so this thing right here is just the same as this, only upside down. So if I need to reverse an array, that's usually what I do. All right, colors. So this, I think those were lambdas, right? Well, that's a subroutine, but the rest of these are all lambdas. Now I can't use, unfortunately, there's no way to do colors with lambdas. If there is, please tell me, because I would love to learn about it. So this is a user-defined function in VBA, which is just, get color. It also, see here, there's two different colors. So it should, if I point at the correct cell here, it should tell us both colors. So if I point at this cell here, it counts as 3 colors, even though it's really only 2. All right, it's 1, 2, 3 colors. So you get those colors here. The one thing that's important to keep in mind about all the VBA functions is that they do not update unless you press Control Alt F9, or like if you go in the cell and press Enter, it'll update again, right? So if this changes color, the VBA, this didn't change, right? Like the Excel has no way to know that this is supposed to change because it doesn't have dependency. So what I do is I do Control Alt F9, and now all the user-defined functions in the whole workbook will recalculate, and that will give me the value I was looking for, right? This is a subroutine to fill in colors, right? So let's say none of these were filled in, and I had like a map and I wanted to fill it in, right? So I like selected these with Control. Right, so I got those selected, and I say fill color, and then it it fills up the colors here, like filling in a map legend, which is useful in the Excel esports world. And then finally, we got a sub to do right background color, right? So if I just select the cells that I want to add the background color for, and I click right background color, there they go. And this will handle the gradients also. All right, next is grids and maps. Lots of stuff here. First of all is arrow move, right? Which is a very common Excel esports thing. Start with Z20, and I want to go that direction 2 spaces. All right, so if I go 2 directions, 2 down and 2 to the right, starting at Z20, right? So here's column Z, right? So 1 over is AA, 2 over is AB, right? So AB and then 21 down to 22. So that's how arrow move works. You can also add boundaries, right? So if I said that, okay, well, this sheet only goes to Z50, this maze that the imaginary monkey is in or whatever, right, only goes down to Z. So in the default, I have what's called push mode. Push mode, it will go as far as it can until it hits the wall in whatever direction it can go, right? So it starts in AB22, it starts in Z20. It wants to go all the way to AB22, but it can't. It hits the wall at Z, right? It's not anywhere near 50. It doesn't have a problem going down roads, but it can't go more to the right than Z. So it goes down as far as it's supposed to, right? It still goes down to row 22, but it stops at Z because I told it that that's where the wall is. You can also turn off push mode, in which case an out of bounds move will just be canceled, right? In this case, it's trying to go down 2, and it looks and it says, no, that's out of bounds. So it just returns the starting cell, which is also useful sometimes. Next is the distance formula, right? So I've got 3 different distance formulas to determine distances between references, right? The first one is the chessboard distance, also known as the Chebyshev distance. It's how many moves does it take a king in chess to get there. The taxi cab or Manhattan distance is diagonal. If you set diagonal allowed to 0, that means that you will be going like a taxi cab in Manhattan, right? And that I mean, there's Wikipedia pages on all this stuff if you're interested in learning more about the geometry. Pythagorean theorem here. If you want to do, a squared plus b squared equals c squared, that's how you do that. You can also turn on one of the options here is print components, which will show these arrows, right? So this is just this first one again, right? So the distance, the chessboard distance, what does the king do to get from Z20 to AC22? Well, first the king goes 2 diagonal and then 1 to the right. And when you do that, right, one of these is always empty, right? You never would have to do both of these, right? You go diagonal first as far as you need to line up one of them at least, and then you line up the other one like this. Taxi cab, right? This time with no diagonal moves, it goes down 2 and then right 3 and gets there. This is the same thing, but it adds the third leg of the triangle, the Pythagorean theorem. Just don't be fooled, because this is a perfect 45-degree angle because those are the only arrows that exist. But like in real life, that triangle side is not going to be 45 degrees unless these are equal, which they're not. So that is my distance formula. Flood fill is this is a subroutine, right? So you take something like this, right? And then you say, okay, well, I want to flood fill. And what it's going to do is it's going to flood each of these until it hits a wall or until it hits a color change, right? So do this, and now you've got these regions here, A, B, C, D, E. LC to NC, letter column to number column, right? So, from A to XFD corresponds to one, these are the column letters, right? 18,278, right? And reverse. So AZ becomes 52, 52 becomes AZ. Next, neighbors count. We're going to play Minecraft with this. This one, neighbors count and neighbors list are VBA functions. They probably should be Lambdas. I want to turn these into Lambdas to make them, because remember, with a VBA function, you got to use Control Alt F9, and it will only update once during a what if table, which is kind of a problem sometimes. So someday I hope to make these Lambdas, but for now they're VBA functions. So neighbors count is like a Minecraft, sorry, not Minecraft, Minesweeper, if you remember that old game, right? You press these things, and how many mines, how many, of these bombs are there to eat within one cell of each of these, right? So this cell right here has 1, 2, 3. This cell has 1, this cell has 1. And I've got options here, right? So you can turn diagonal off and on, and you can turn off whether the self counts off and on, and you can go farther distance, right? So this one has diagonal off, does not count itself, and looks at a distance of 2. So like this is a 0, right? So the self isn't, so this cell, right? The self bomb is not counting, and there's no bombs within 2 here, right? So that's a 0 for this option. Next is neighbors list, which lists the most common. My default for this is just to list the 8 surrounding cells. This is kind of used all the time in VBA. So I tell it B46. It does not list itself, but it does list the 8 neighbors immediately around it. There's also optional options here to make it size and diagonal. So here is distance 2 with no diagonals and still no boundaries, right? So all of these are showing up here. Can also add boundaries, right? So if I tell it that X is a boundary here, you can't go farther than X, then I only get these, right? The other part that would be here is cut off by the boundary. And it's not because I put a line there, right? It's because I said here in the function, right, that there's a boundary there, so it knows not to include those. This is RC to ref, so it takes RC as row column. So it takes the row column coordinates and turns them to a reference, or does the reverse. This is, I probably shouldn't even have a Lambda for this, since it's literally just the address function with a particular option set, but I wanted to have the reverse of this. This one is not as simple. You could do this simply with indirect, but I'm not using indirect because it's non-volatile. So this is actually like counting the BZ. This is actually figuring out BZ is 78 without using indirect. Same thing up here. None of these are volatile. All right, rotate arrow. So I take an arrow and I move it, 45 degrees times the number of steps. Default is clockwise. You can also do counterclockwise. So if the arrow starts pointing to the right and you rotate it 3 directions, right, then it's 1, 2, 3. If you rotate it, 4 directions, that will reverse it. If you rotate it 8 times, you'll just get the same thing again, right? Next, we're going to do route cost. All right, so this is a Dijkstra-like algorithm that will determine the maze, the shortest path between 2 points on the map, using not the shortest distance, but the shortest cost, the least cost based on each cell having a cost. So let's say this is from the Temple of the Golden Idol case. So let's say this is in the case, and you also get information about how many seconds it takes for the animal to go through each of these terrain, right? So I did a little, so this is just an X lookup on here, right? To say how many seconds it takes. The walls, right, are NA because they're impassable. So then now here's my lambda, right? Route cost based on this whole array here, where you start at 0105, which is here, so that's 0. And it tells you how many seconds it gets to each cell, right? So it's going, 60, 120, 140, how many it takes. And then it goes down every path, right? So to get to here, it goes this way. And to get to here, it goes, this way. It's only like kind of halfway, like to get to here, it could go either this way or this way. But, it always finds the shortest path because of the Dijkstra-like algorithm. This is the same thing, but with diagonal off. If you do not allow, or no, with diagonal on, here I turn diagonal off, right? So here you get very different answers, right? Because of diagonal being, oops, I didn't have it turned on right. Now it's turned on. Here you get very different answers, right? So this is 2580 instead of 3240, and that's because it's cutting the corners, right? Like it goes, from here straight to here. It goes from here straight to here. It does not go through here. It goes from here straight to here. It's cutting corners, which in this case you do not want, but in other cases you probably do. All right, last thing is a subroutine grid fill. This is a simpler maze version where every cell is worth 1. In this case, you can just use colors to make a maze, right? So let's say this is from the Bear Island case. Let's say I took this and just manually turned this into a maze where the green cells here are passable. This white stuff is in the range of the bear, so you cannot touch it. This stuff you can't touch because it's water. This color, this sand, actually is passable, so I changed it into green, right? So now, you highlight all this and you tell it, I want to do maze solver with diagonal, and, it fills it in. Right, so this is the version, starting at the airport, 1, 2, 3, 4, 5, 6, 7, 8. With no diagonal, it takes much longer, right? So 1 to 6, and then 6 over here to 13. So those are my maze solvers. All right, quick history break, just because it was fun. Why are lambdas called lambdas? Well, in computer science, lambda is a function without a name. Of course, we give them names anyway, but what it means is that it doesn't have a name. Anonymous functions are called lambda in Python, Ruby, Lisp, and other programming languages. Almost any programming languages has them, whether they're called lambda or not. The lambda function was introduced into Excel in 2020. That makes Excel the Excel formula language, a Turing-complete programming languages like most other programming language. Lambdas are named for lambda calculus, which is a model of computation invented by Alonzo Church in the 1930s. Alonzo Church was Alan Turing's thesis advisor. But why did he call them lambdas? Well, this is from Wikipedia. So at first, there was X hat already existed for a similar thing, right? So instead of X hat, he made it like wedge X, which was apparent. I don't know. They didn't have the wedge on the typewriters or whatever they were using in the 1930s, so they made it lambda instead. But the funnier answer is someone sent him a postcard first and was like, well, why is it called lambda? And he wrote back on the postcard saying it's called lambda because eeny, meeny, miny, mo. So that's why lambdas are called lambdas. All right, more lambdas. Biggest. So biggest, you look up in one list, right? So this is, I'm checking in this list and returning in this list. What's the biggest number in this list? Return the corresponding value here. So which one of these is the highest? Well, it's the apple, right? So the biggest is the apple. Which one of these is the biggest? Ooh, there's a tie. So which one do you get? You get the first one, the green apple. Just like, because it's X lookup of the max, right? Very useful in Excel esports. Label lookup, right? So this is a kind of this is just a classic like index match, but just kind of simplified it, so I don't have to type index match every time. So this array here, right? I feed it the array addresses, I tell it the row label, and I tell it the column label. So I tell it, red apple price. So it looks up red apple price, gives me the price of the red apple. Next up, sheet data. This is a lookup function. So those, are lambdas. This has to be VBA as far as I know to look up in other sheets. Like you could do it in your own sheet with the lambda, but as far I don't know any way to look up other sheets in lambdas unless someone can tell me. So here you tell it the sheet names, right? So if these are the sheet names, pull out this, right? So this, A1 to B2 is this, this range up here. So I'm pulling out this range from these demo sheets, and then it just kind of shows them in here, tells me the row and column labels, or the addresses, right? The row numbers and column letters. You can also have a flat version optionally, which just has, a column for each sheet. And the addresses are over here. Right here, because I added the history break. This just tells me sheet names, right? This used to be just these, but then I added the history break. So I'll add that is there. So if you take this, sheet names does this. Of course, as always, this, because it's a VBA function, right? If I call this sheet something else, this does not update. If I do enter like that, or if I do Control Alt F9, then it does. But it will not update otherwise. What are these? These are lookup demos. All right, so if I do Control Alt F9, it recalculated all of the user-defined functions. Back to lambdas, which do not require, which know that lambdas are smart because they know what they depend on, and they only update when they're supposed to. This is just the opposite of the biggest, right? Is the smallest, so it looks up the numbers here, finds the lowest price, and says the blueberry is the lowest price. There's a tie here, so again, it gives you the first one. X indirect is a non-volatile version of indirect. So volatile function, right, is one that updates every single time you do anything in the world, which usually slows down your sheets, like the indirect function. So this is a non-volatile version of it. I don't really use this anymore. I just kept it around just in case, because it only updates when you do Control Alt F9, right? Or when it only updates once per what if table. So that, I don't know, that causes problems for me. So I don't usually use that, but it's there if I need it. All right, math demos is selections. This is a VBA function. Maybe someday I'll figure out how to make this a lambda, but for now it's a VBA function. So you start with an array here. So selections here means permutations and combinations, right? I'm in my math section, so we're doing some math. So I tell it the array, and I tell it that I want groups of 2, and I say 0 for order matters. So if order does not matter, those are combinations, right? So I get all the combinations of 2. If I tell it yes, order matters, I get all the permutations. If I want repeats, right? So here's combinations with repeats, right? So now you could have, even though there's only one 9 of spades here, I told it to allow repeats. So it took these and added in, one each for the 4 repeated, as if you were drawing with replacement, for example. And here is countdown mode. So countdown mode is kind of similar to this, but instead of starting, so I told it I want 3 is the size, the in size, right? Order does not matter. Repeats are not allowed, but do countdown mode. So countdown mode is, first of all, gives me groups of 3, then it gives me groups of 2, then it gives me groups of 1. So whatever in I ask for, it gives me in -1 and -2 down to 1, which is, useful sometimes. This is to do conversions, because I hate conversions. So I made my own version of the, Excel has a built-in convert function that works kind of like this, but it only gives you like real world conversions. And in Excel Esports, we often have, obscure or made up conversions, or you could use it for like prices also. So like, let's say that in this case, a pint of something costs $7, right? A pint of everything doesn't cost. That's not like a real world rule, but like in a case, it might be a rule that a pint of something costs $7. Dollar always has 10 dimes, right? But that's not in Excel's list of conversions. But I can add it, right? So if you feed it this table, it can do proportional conversion, right? So if I tell it how many, if I have a quarter of a quart, how many pints is that? It can, multiply and say, okay, well, that's half a pint. It can also do a reverse conversion, right? So if I do the reverse of that, it knows to give the reciprocal. You can do a self conversion, right? Which is, I just say pint to pint is just itself, right? So it just multiplies by 1. And finally, the tricky part is the chain conversion. So how many dimes does it take to buy 1 gallon of whatever this is, right? So it converts from gallon to pints and pints to quarts and then converts all the way to dimes. Does the whole thing as a recursive chain, so you can do conversions without actually having to do conversions. Xmod. So the mod function is, the modulo, which is a fancy word for the remainder, right, in division. So if you divide 1 by 3, 2 by 3, these are the remainders, right? It cycles 1, 0, 1, 1, 2, 0, 1, 2, 0, 1, 2, 0, etc. But in Excel, we don't like these zeros. We like to count 1-based counting. So instead, I do a 1-based modulo that instead of giving me, B, instead of giving me 3, instead of giving me 0, right? If it's divisible by B, if it's divisible by 3 in this case, then I just get 3. So it's 1, 2, 3, 1, 2, 3 instead of 1, 2, 0. X rank. So X rank is just it's exactly the same as the rank function, right? So here's the built-in rank function ranking these numbers, right? With the highest number getting rank number 1. This does exactly the same thing. The only thing that's different is that it accepts arrays as an argument, right? So the rank function is one of the, slightly older functions that does not, it only takes references and not arrays. So if you tell it, rank for this reference, it's fine. But if you try to turn it into, if it's an array, right? Like if you just take this reference and then filter it by true, right? Now it's an array and it can't, it's like there's a problem with your formula. It can't do that. This, however, is fine. It works with arrays. X sequence is just, like you got, here's a built-in sequence from 1 to 9. My sequence, you give it the start and stop value. You tell it how many to count by. You tell it how many times you want to repeat each element. And it tells me how many times you want to repeat the whole thing, right? So here is 1 to 4 repeating each element once. Here is 1 to 4 repeating the whole cycle once. And here is 1 to 2 repeating each element once and repeating the whole cycle once. Twice total. Repeating it once to get a total of 2 times, if that makes sense. Part of the you can use like let's say you want a repeated, let's say you want 10 ones, 10 twos, 10 threes, right? You could tell it to step by 1/10 and get 10 ones, 10 twos, 10 threes, etc. Except that causes floating point rounding issues, right? So like if you do this, you actually get 11, like you're supposed to get 10 sixes, but you actually get 11 sixes because of floating point errors. This X sequence does not fix floating point errors. If you put decimals or fractions into here, you will still get floating point errors. But it makes it less now because of the repeats. I don't have to use fractions in order to get repeats. I can get repeats with only integers. So I avoid the floating point errors. So I mentioned before I made an X rank because the rank function, built-in rank function, does not take arrays. That's not the only function that doesn't take arrays, right? So count ifs, sum if, and sum ifs are all things that would be useful in Excel Esports a lot, except that they don't take arrays, right? So if you feed it, A1 pound, that's fine. It knows that that's still a reference. But if you feed it sequence 10, for example, or if you feed it, filter something by anything, it's gonna break, right? So these count ifs just break because it cannot handle arrays, right? So one thing I could do is I could make an X count if, X count, I could make X versions of all these that work with arrays, but I don't do that because I have a different way I like to do it. You could also do it with like filter and count the number of rows, but you got to be careful here because like if the filter is empty, it gives an error, right? It doesn't, I want this to be 0, right? There's no 999 over here. So I want it to say 0, but I get an error instead because when it filters, there's nothing left. So it's in filter error. All right. So what's my count if replacement? Well, it's a Boolean mask on a double unary operator, which is a fancy way of saying, you know, minus minus this thing equals 700, right? So there's 2 of them, right? So that's countIf, right? How in this array, how many is equal to that? That just gives me a bunch of trues, falses. I use minus minus to turn the true falses into 1s and 0s. And that works. It also gives you a 0 if it's supposed to be a 0. If you have multiples, right? Multiple, if you want count ifs plural, then you multiply, right? So you just multiply these conditionals, right? These Boolean masks, multiply them by each other, and that's the same thing as like as and, right? Like both of these have got to be true. So I want the numbers that are equal to 700 in this array, but in this array also has to be less than 2. So, you know, the only row that applies is this one, right? Like if I made it less than 5, now this row is okay too. But, you know, if it's less than 2, this row is not okay. So there's only one row that meets both of these criteria. So if I want to make these count ifs, sum ifs, now I just multiply by the original value, right? So now instead of 2, I get 700, right? Now instead of 1, I get 700, right? So that's a replacement for sum, count ifs, sum ifs, all that stuff is now replaced without needing to add special lambdas. All right, last category, strings. Count substring. How many i's are there in indispensable? There are 2 i's in indispensable. You can count big string, small strings. It is not case sensitive by default. Die pips just takes, you know, dice, turns them into numbers. Very simple lambda, just, you know, character minus whatever the Unicode is where they start. It also works with multiple dice, right? So it takes this and turns it into an array. Start an array, you know, turns it into, oh, you can't, you know, if it starts an array, then it turns it like this. If you have an array like this, you got to concatenate it first in order to get all 4 of the dice, right? Offset letter is for you know, code breaking, seizure shift. So if you take, you know, hi, my name is Eric, and shift each one by 20, you get this code here. You can also do, so then you do minus 20 to reverse it. So I did, you know, take this and do minus 22, that reverses it. 6 is the same as minus 20, right? Because 26 is the same as going all the way back around. So offset 6 is the same as negative 20. All right, now these next couple are based on regular expressions, regex, only letters. Just keeps the letters from this and gets rid of everything else. It also works with arrays, right? So with each element in this array, I get rid of all the symbols and numbers and everything and get only the letters. Here is another, you know, basically the opposite of that, right? Is if you do only numbers, that just keeps the digits, no symbols, no spaces, no nothing. Same thing, you know, with an array, you get just the digits, and it turns them into numbers for real, right? So like this is already a number without having to, you know, multiply by 1 or use the minus minus trick. String reverse, takes a string and reverse it. So if you want to check if it's a palindrome, you know, equal to itself, not case sensitive, right? So even though the capitals of this palindrome change, it still counts. String to array, right? Takes a string and makes it, you know, a vertical array, include it, you know, the space and the exclamation mark get their own cells. If you start out with a vertical array, now you get a 2-dimensional array, right? Which is each of these stacked on each other, right? Which is sometimes useful in these cases. And finally, last but not least, is X text split. This is just I found myself over and over again typing to call trim text split. So this just does to call trim and text split all at the same time and gives you a trimmed column version for split of a delimited list. And that is my VBAs and my Lambdas. Like I said, you can download this file at the link in the description. Good luck with your Excel esports fun. Thank you for watching.